All right, so where were we? Here. So we had done the projection of u onto v. So remember what's happening right there is that your projection vector plus this other piece right here adds up to u. So we're going to call that w right there. So w plus my projection vector of u onto v adds up to u, right? And so you can call that, sometimes they call that like w1 plus w2 equals u. And so however you want to do it, but here we go with that. So I want to be able to know, so basically I know this vector because it was given to me. I just figured out this vector. I want to know w, okay? So if I want to know w, I will have to do u minus my projection vector, okay, of u onto v. So u is 3, -5, minus my projection vector of 6/5 and 2/5 equals my answer. So 3 minus 6/5, so that's 15/5 minus 6/5, so that's 9/5. And -5, so that'd be 25/5. So -25/5 minus 2/5, that's -27/5. Okay, so I am able to write u as the sum of two vectors. Well, all I'm doing is writing this out. U equals my w vector, which I just found, plus my projection vector, which I found earlier. Okay, so these are the two vectors here, these two here, that make up the motion of going in the direction of u. All right, so let's apply this to this problem here. A 600-pound boat sits on a ramp inclined at 30 degrees. What force is required to keep the boat from rolling down the ramp? Like how much does the the brakes have to hold, or if you have like a block of wood sitting there, or some kind of weight there, so your boat doesn't roll down the ramp and things like that. All right, so let's see what's going on here. So what we're trying to do is we are projecting the boat onto the ramp. Okay. All right. So the ramp is my F1 in this picture. All right. So that is, oh goodness, let me get my glasses. Oh, I can see it now. All right. So F1, that's pushing onto the ramp here. I have my force due to gravity, my F right there. That's my boat. Okay, and basically we are saying here that my F1 and F2, so basically this F1 and this F2 right here, are basically adding up to F right there. Okay, so here we go. So my boat, let's come up with a vector for the boat. Right, it's 600 pounds, and I know that the boat itself, my F right here, the boat is pushing downwards. So the direction of that, it's 600 pounds, and it's going down, so that is the vector 0, -1. So my boat is 0 and -600. All right, the ramp, okay, the ramp is said 30 degrees. And the ramp doesn't have a magnitude. It's just like the angle, the ramp itself. So that would be cosine of 30 and sine of 30. Okay, so that is radical 3/2 and 1/2. All right, so I am trying to find the projection of the boat onto the ramp. Okay, so that means I'm going to dot these two things. So when I dot these two things, I get 0 plus negative 600 times a half. So I get negative 300 over, remember I'm doing my projection formula right here, over the this part, the magnitude squared, right there, magnitude squared of this vector right here. Okay, so my ramp, magnitude squared of that. So my ramp, well, if I do the magnitude of this is a unit circle value, so it's going to be 1. The square root of this thing squared plus that thing squared, that'll be the square root of 3/4 plus 1/4. So the square root of 4/4, which is 1. Squared, I get 1. And then next to it goes the vector that's down here as well. So v goes over here. Okay. All right, so vector v, this ramp right here, is this guy right there. So 3/2 and 1/2. So basically, I'm just multiplying this thing by negative 300. So I get negative 150, radical 3, and I get negative 150. So that is the vector that I'm trying to stop from happening, and so I am wanting to know the magnitude of this thing. So the magnitude of that is the square root, square that part, plus negative 150. So that's calculator work. It comes out to 300 pounds. So even though the boat weighs 600, I guess what's happening here is the ramp is helping you. You only got to stop 300 of those pounds. All right. So last thing here, work. So in physics, mechanical work is the amount of energy transferred by a force acting through a distance. So your work is your magnitude of your force times your distance. So oftentimes you write it like that, magnitude of your force times the distance that you have to do this for, right? Times your distance. So, you know, the length of the vector that you do it for. All right. If the force is not along the line of motion, we can use our projection formula from earlier. So the work then will be the magnitude of your projection vector, the projection of your force onto the line of motion, onto the vector of motion, but still multiplied by the magnitude of the distance, right, or like the distance you go, okay? So we're going to do this little guy right here. So we're closing a sliding door. The person pulls a rope, so they're pulling the rope down there with a constant force of 50 pounds. So I have my magnitude of my force is my 50, right? But I am pulling my vector of my force right here is 60 degrees right there, because I am not pulling along my line of motion, so I have to make up a vector for that. Okay, so my force vector is going to be 50 pounds of force times the cosine of the angle is negative 60, and the sine of the angle. All right, so when you do this, this is 50. 60 degrees angle is 1/2, and negative radical 3/2. So I get 25 and negative 25 radical 3. This is my force vector. And my line of motion, my motion is this direction, like horizontal. So that will be, and it doesn't have like a magnitude to it. This is just the direction I'm moving. So I'm trying to eventually get to this right here. So that is just in the direction 1, 0. Okay. All right, so I need the projection of my force onto my line of motion. So I need the direction, we'll call this one L, the projection of my force onto my line of motion. So I dot them up top. So I dot these two things, so basically 25 times 1 and this one times 0, so 25. And on the bottom, I do the magnitude of this thing squared. Well, the magnitude of this vector would be 1, because it's only 1 unit long, and square that, and I get 1. and times this vector again. This one right here goes here again, so 1, 0. So my projection vector is 25, 0. Okay. All right, so we are going to, remember my work is the magnitude of that projection vector times the amount of the length with the distance with which I pull it. All right, so my distance, I have to close this door, it's 12 feet, so I'm going to be multiplying, my distance is 12, and the magnitude of this guy, well, it's only 25 units long in one direction, so it's 25 times 12, and 25 times 12 is 300. And in this case, you would say 300 foot-pounds, okay, because this was in feet. This is 25 pounds of force. All right, that is it. So you should be able to do these problems now. Bye-bye.